Our next presenter is Mr. Somenath Chakraborty. He is from the University of Southern Mississippi, and his title of his presentation is Structural Health Monitoring Using Artificial Intelligence Technique. So over to you, Mr. Somnath.
Hello, everyone. Thank you for giving me the opportunity to present my work. I am sharing my screen right now. I think it will become within like 1-2 minutes. Is my screen visible now?
Yes, we can say.
Yeah, so I am starting my presentations. The topic is structural health monitoring using artificial intelligence technique. And especially now this work is jointly done by me and my supervisor, ex-alumni, IIT Kanpur, Dr. Bedu Murali. And we've done this work at our lab at the School of Computing Sciences and Computer Engineering at the University of Southern Mississippi. So the today's agenda is I will give an introductory speech on structural health monitoring, then I show some research domain in this current area, and what are the applications that can be applied with this domain of research. And then I talk about human health monitoring, and I will show our current works and in question and answer sessions. So structural health monitoring, basically a very holistic in nature. It is a system in a method of evaluating and monitoring structural health parameter with a lot of interdisciplinary domains ranging from artificial intelligence, AOT, big data, like sensor, electronics, and other engineering departments that is embedded with this task. Especially nowadays, a huge lot of machine learning models, especially deep neural network models and artificial intelligence model like reinforcement model, where multi-environment learning can be possible within the health parameters of global populations. In 2021 alone, like IoT Analytics stated that the global number of connected IoT devices grow more than 9%. Currently, at 12.3 billion active endpoints are there, which was just 11.3 in 2020. That is also a very big number. And the global Internet of Medical Things, which are especially focused on medical application designed of sensory elements and other related hardware, that is expected to having like $158 billion valuation in 2022 alone, up from 41 billion that was in 2017, according to Business Insider. Especially like even any small like locality where we use a lot of smartphone, and smartphone based SHM is also very cost effective and resilient system. There are certain aspects in this health monitoring system as well, because it uses like sensor and different other integrated system that prone to security hacks and other kind of vulnerability that need to be like sorted out with the framework of like mobile cloud computing, edge computing, and fog computing. So basically, the current scenario is that artificial intelligence is mostly used for automations purposes of the structural health monitoring system. And the emergence of artificial intelligence, not only for automation, but also a lot of holistic learning and giving very prompt and real-time fashions delivery of the systems, whether it is a predictive model, or whether it is a monitoring model, or whether it is a real-life applications. So there are medical sciences and epidemiology involved in this area. And why cloud computing or mobile cloud computing? Because like sensors, previously we like have different kind of hardware sensors based on microcontroller, microchips, but they do not have very sophisticated user interface and fully grown operating system that is very prone to hack and also difficult to integrate with a integrated server that can be automatically managed and automatically perform its operation. So a lot of manual works need to be done previously, but currently with the help of artificial intelligence and distributed mobile cloud computing, and especially Internet of Things and big data analysis innovations, these are now possible, and still many challenges are remaining. And also like hardware oscillations from the GPU and multi-core central processing systems is also applied in this area. So we can say that in today's world, structural health monitoring is very well equipped and integrated into real-time functioning. Basically, for human health monitoring, we know a lot of human parameters can easily be detected by wearable sensor. And especially like initially we use like IoT devices. Currently that is integrated with edge devices. We call it edge devices because there is automatic cloud computing ambitions happen within that edge devices. It's very similar kind of sensor, but it is actually integrated with a deployment machine tools that is and there are different kind of deployment can be performed using PLC or other kind of like Vertex AX, AutoML or Node-RED like that. These are very easy to use nowadays, and very little amount of coding and integration required. Previously, like when we are working on ASIC chips like that, like application specific integrated circuit that doesn't actually come up with integrations of edge devices, but currently they are able to deploy with the AI framework and model deployment tools. And those actually integrated with the mobile cloud computing, and that can be from the server end monitor easily. So these are the heart parameters. All we know, electrocardiography, ECG, heart rate, and oxygen saturation. These are easily monitored nowadays. Blood pressure and temperature sensor, even like diabetic parameters like glucose measurement, heart rate, and today's technology is already available for like implanting different microchips into body that does not hamper the any kind of like body health conditions, but that can provide real-time glucose monitoring throughout 24/7. And there are many image capturing devices currently uses, like there are radiological devices that can be applied and that can be automated. So any kind of radiological like X-ray, CT scan can be automated, and that can be processed and analyzed with different kind of AI systems. I like to show what are the industries in this market. This is my article. Currently, like they call it AIoT, that is artificial intelligence of things, because so much like artificial intelligence is used in this area. Especially like I already talked about how the health is monitored, and like one of my recent publications in this area also have a feature in World Health Organizations. So especially like is my website visible to all?
Yes, we can see.
Okay. So especially like there are so many companies that are working on these areas, from Dexcom to Honeywell, Medtronic, Philips Healthcare, ResMed, and Sensonics, and many others. They are especially like designing different kind of sensor health monitoring systems and other health monitoring tools, and that is totally integrated in a holistic environment, like with all kinds of engineers and all kind of specialist and expert coming into this field. So there are some publications I already have in this area. This publication that I already talked about, it is also features in World Health Organization. Basically, in this application, we try to analyze the X-ray. I will show another publication in this area rather than this, but it is very similar. But it is a new kind of thing. That's why I'm showing this research here. Here we actually collected many data. So what happened when the pandemic broke up, very few amount of positive COVID-19 X-ray images are available. And especially for deep neural network model or any machine learning model, if you have a very shorter amount of data, you cannot make that model efficient. Initially, whatever publication we see on 2020, they lack like data imbalance issues. They lack the data that required to make their model most efficient. So in our model, we make sure that it should be not having any kind of data imbalance issues. And currently, actually, we have a lot of COVID-19 positive data available, but still with different variant, the research is going on. Basically what we do, we actually taken a lot of images which are actually having three kind of category. One is COVID-19 positive or infected. Another one is pneumonia. We know that COVID-19 is also a variety of pneumonia, but there are other kind of coronaviruses, pneumonia, they are existed. So that is another category, and others are normal X-ray images. We need to process them first with different kind of processing tool like histogram normalization and other kind of things, and then we segment using UNIT. After getting the lung contour, we actually proposed a EML model that is an ensemble of different deep neural network model, and then we go for the classification. So basically, I use four kind of deep neural network model, that is ResNet 18, ResNet 50, AlexNet, and DenseNet. These are, you can say, like the benchmark deep neural network model currently available. While ensemble, then what the advantage is that like if we use only one network, it may have local biases or local like minima problems that can may lead to some kind of inaccurate results. That's why we ensemble them, and then we classify them with the feature classification model, like that. Why we use ensemble? Because as I mentioned, that it gives better accuracy, lowering error by having optimized values, higher consistency. It always try to avoid the overfitting issues with the deep neural network model. And it actually perform very well on optimizing biases and other parameters like variance neutrality. It provide the optimum way. So the results are like described in this terminology. We call it sensitivity or recall, specificity, positive predictive value or precision, and accuracy. And we already achieve like a very good amount of accuracy in our EML model too. And these are the comparison analysis, but there is a caveat in comparison analysis, like we need to compare with the data that we actually using our model. So previously there are many, even like there are inability of open repository, but whatever available, we actually use them. and work on them to process the values so that we can compare them with the existing model. So our proposed model is performing quite better in this respect. And in future works, we actually thinking of integrating our ensemble model and other deep neural network model with a distributed cloud computing environment. I already show that I also have a publications on distributed cloud computing environment, and that we are trying to integrate both of these so that we can make a complete system on that. So these are the references. Uh, Thank you, everyone. And if you have any question, please ask me.
Thank you, Mr. Somnath, for your nice presentation. Now, may I request if from audience, if you have any questions, you may raise.
Hello.
Hello.
Yeah. Hello. Hello.
Yes,
Yeah, we can
your
hear.
voice is
Yeah.
audible.
Yeah, Dr. Somnath, I am having a question regarding that. Regarding the health monitoring, so you are using the image processing for image processing data you are using for the neural network.
Yes, medical image processing.
Okay, medical image processing. So from that the data you are training the neural network.
Yes. So like as I showed already, so I have many other publication. I am showing this research only. So this research actually fully based on like X-ray images, like it is collecting data, and those are radiological data, real data, and marketed by the radiologist. Which one is normal? Which one is COVID positive? And basically, with that data, we can make a predictive diagnostic model that can help to detect any kind of images based on and it has the feature of classification, so it can classify and predict. So there are basically two kind of neural network used. One is for the segmentation purpose. Segmentation means just we need to the lung contour. But there are other way also, like many people, many researchers in this area, they directly fed those, but with actually use segmentation, so we can have more accuracy on them. And like what we previously done, that is a feature on World Health Organization, that we only use that time ResNet 18. But currently we are using some ensemble. It is a approach to like optimize, but there is a drawback too for ensemble model as well that I like to speak on. That sometimes it is very hard to train because it has so much complication of very high-end deep neural network model. But we use GPU. We have 4 GPU systems at our lab, so we can easily do that. And after training, basically when training is done and your model is deployed, then it doesn't take much time to use those. I think I can answer your question, right?
Yeah, I was having one question in my mind regarding. Can I ask?
Yes, obviously.
Yeah. So my point was that if this particular process can be used for by using the data from the images for the health monitoring of like lungs or some other parts. So is it possible that we can use the sound data, means data like heartbeats? For example, we wanted to diagnose the health of our heart. So can we use the sound through stethoscope, some sort of mean of some sensors? We can take that data and use this neural network to train to know the health of our heart. Is it possible?
Yes, actually, it is in current practice, like ECG and different heartbeats and like heart condition can be monitored. Even the there are you can make a deep neural network model with the output coming from the different questionnaires. Normally, any kind of medical setup, they initially fed to a chamber where there are so many questions asked, basically analyzing your disease by those questions. So that can be also automated. Currently, that is actually not heavily used, but that is also currently industry standard and already in practice.
But I think if that can actually increase the accuracy of diagnosis compared to the traditional methods, if I'm not wrong.
Yes, obviously, basically done that, but this um, process actually what we actually do. This is a radiological like automations. Basically, what deep neural network model helps, it help to automate and give more confidence. We are not replacing the current practices, but providing the medical fraternity the added tool by which they feel more confident, like if they can analyze with only the doctor's experience, that sometime may have human error, but if they have automated tool that is analyzed with thousands and millions of data and give them more accurate and more precise result, then the doctor also feel more confident about that.
Okay, thank you very much. I definitely would like to contact you in case if I'll have some sort of this kind of work in future. So I'll be very happy to just contact with you.
Yeah, sure. And you can easily reach by my LinkedIn or my email, anything. Thank you
Okay,
so much.
thank you very much for your nice presentation.
Okay.
Okay, we have another question from Aniruddha. So Aniruddha, you can ask.
Yeah, so good morning, Mr. Chakraborty. I think it's morning in US now.
Yes, it's early morning. I wake up at 4:30 a.m. today.
So I have two questions for you. So the first question is regarding, like, you have shown the detection of diseases using X-ray images. So can you let us know, like, what is the kind of disease the algorithm has detected, and what is the accuracy of that detection, like the false positives cases?
Yeah.
And my second question is, okay, first time we'll have that, and then we can go to the second one.
So, yeah. As I already mentioned, now my screen is visible, right?
Yeah, we can see your screen.
Yeah. So, especially like when we feed to the systems, it basically able to detect three kind of things. Like one is for COVID-19 infected. That is our main goal, to detect COVID-19 through any kind of X-ray images. So if you feed the system for testing any X-ray images that can detect whether that is COVID-19 positive or not. But along with that, we also make another classification for pneumonia detection, because like for some people who have some kind of issues with pneumonia symptom that is very similar to COVID-19, and they get afraid so much that I have pneumonia and like that. So if this
we get the point.
system,
I get the point.
Yeah.
I mean, what I'm asking is, what is the accuracy of this prediction? Like, if I take 100 images, out of 100
so
images,
I am telling you. So basically, there are two pathological and clinical way to, like, there is RT-PCR, that is the golden standard, and there is rapid antigen test. RT-PCR having accuracy of only 60 to 70%. And rapid antigens test has accuracy of 50 to 49%, like 49 to 50 something. So you can understand that how much defective that even like the new Delta variant, which actually having an Omicron variant, especially having a T spike protein in their mutations, and that cannot be detected by the kit for RT-PCR test. But I'm glad to state that this model also have like this Delta and Omicron variant embedded with this model, and it has accuracy of 93.56% with sensitivity 91.24%.
What is the sample size of the test, and on how many?
The data set that we used actually 6,641 samples, and out of which 1,684 have COVID-19 positive. 1,845 is pneumonia, and 3,112 are healthy individuals. So you can see this data set is very well distributed. Like if you go through the different publications on COVID-19 on 2020, even 2021 January, February papers, you will hardly find this amount of, they use like 200, 300, 500 COVID-19 positive, and some may use like 200 COVID-19 positive, and they slice it and make it to make a bigger data set so that their model cannot be like, there is a problem called biasing of the data set if you have very small amount of data set and you feed to the deep neural network models. I think now I answered your question, right?
Yeah, so that's fine. I got the second question that I was coming in, since the first part of your presentation, you were talking about structural health monitoring.
Yeah.
Okay. So structural health monitoring, as we understand, even if I read Wikipedia also, at first line it said it involves the observation and analysis of system over time using periodically sampled responses pertaining to engineering structures such as bridges and buildings. So, I mean, I'm trying to understand, how do you relate the human health to the, to the description of structural health monitoring? Like, I understand this work is perfectly fine in the detection and diagnosis part of the thing, but structural health monitoring specifically address in the engineering structures. So how do you fit this idea in the concept of SHM?
Yes, very pertinent questions. I am happy to answer this. Basically, I also given some talk other places, like the perception of robotics. Like when we perceive robotics, we only think about mechanical flexible robots that is visible, and that can be, that is may have some machinery parts, but currently, like, we forgot about the soft robot. Like when we Google on anything, that actually many artificial intelligence work over there, that is also like AI systems. And structural health monitoring basically focus on how we can monitor and structure our human health with different kind of engineering application. Basically, this is also engineering means not only in the like hardware domain, but also in software domains, and especially this structural health monitoring need both. That's why I mentioned that it is more holistic in nature. We need like artificial intelligence, we need like integrated hardware, and especially like there are different kind of machines that are used. That is also part of structural health monitoring. So structural health monitoring is designing system that can monitor and give us all kind of health related issues, because it is a health monitoring I am focusing on. Is my answer make sense?
Yeah, so we have a perspective, we have an entire idea, but what I am asking is like, moving forward, can we actually use the term structural health monitoring for biological things? That's my understanding that I want to get.
Yeah, no, there is a we cannot. There are biological. When you say biological, it means like there are so many clinical like analysis and like pathological. So there is a distinction. Like there is when you do some kind of like testing. Suppose you are doing RT-PCR. So your sample is taken and that is analyzed with some chemical, like organic and inorganic chemicals, and that can give you some kind of results that whether that patient has COVID-19 or any kind of disease. That doesn't or may not involve those data processed by artificial intelligence techniques, but currently that is also in the research area, that how we can automate different kind of pathological and clinical data, or like even today, like different kind of drug discovery. Previously, we only rely on pathological and clinical processes. Currently, simulation is used heavily, and artificial intelligence also help a lot in drug discovery. Basically, biological process, when you come that point, that limits the boundary actually.
Okay, okay. Thank you. I got the answer.
Yeah. Any more question? I am happy to answer.
I have just one single question, Mr. Somnath. Regarding that, you use that CXR image for that disease detection. So this actually, as per I know, these images are of very high sizes, means big size. Size are very big. So, but when we use this traditional means machine learning, this algorithms, AI-based algorithms, so that training, they generally are trained on very smaller size of images. So, how much training time is means how much training time it requires for these big images to train in this kind of system?
Yeah, so if you the machine learning or deep neural network models are like evolving very rapidly after 2017 onwards, when the GPU accelerations we have from the GPU point of view. So suppose it also depend on which system you are actually using. So like in our university, we have like supercomputing systems where even I have the account and we can use and train those models. But especially we use 4 GPU system that is even more powerful than that. And that can be so the time actually depends on which hardware you are running on. You are getting my point?
I'm getting my point, because why I asking, one was the training time, and after that detection time with this image size, the detection time is also increases. Means when we take with this thing, big images.
No, suppose if you train those model, so what happen actually in the training process, there are different kind of biases and parameter that is learned. So like I already showed you, like this when we use some kind of ResNet model or ResNet 50, AlexNet, DenseNet, these model actually well trained, and we just using some kind of transfer learning techniques that can give weightages and parameter values. So this network actually train on millions of data, and they have the values. So you just use those network
Yes,
any kind of.
Yeah, Mr. Somnath, I got your point. I had just one more question regarding that. You also train with the UNet. This is, I think, specifically used for this medical images. So how that is scored compared to this one, this ensembled one?
No, this ensemble actually the segmentation process done by the unit.
Okay.
So after getting the segmentations, like any deep neural network predictive model, there are actually different layers, and within that layers, you have different kind of feature generation layer. After getting those feature generation layers, you need to have some kind of classification layers. So initially, like in this model, we actually segment with unit. And why we use unit? Because unit is currently heavily used in medical segmentation modeling, because there are other kind of image detection models are there, image classification models are there. But when we using medical images, the problem is that medical images are having a lot of precise details within an image. Suppose for X-ray or CT scan, there are different points which may not be easily detected by other models. But UNet is heavily used on medical images. That's why we use UNet model for segmentation. I think gives your answer, right?
Yes, I got the answer. Thank you. Thank you, Mr. Somnath. Thank you so much.
Yeah. Any other question?
Do we have any other question? Okay, so thank you, Dr. Somnath, for your nice presentation, and you have cleared a lot of questions of the other members. So thank you once again for your presentation.